Hello once again. So we are back here again for this session on vector algebra. So in the last two sessions, what we have seen what is a scalar, what is a vector, how can we represent a vector in the two-dimensional space as well as in three-dimensional space. Now today's lecture we will see some basic terminologies and some special type of vectors. So to start with, we talk about modulus of a vector. Now this is a very useful term, and modulus is nothing but the magnitude of the vector. So magnitude of a vector A is called the modulus of the vector A and is written as shown here. This is the vector A within two parallel bars. And if we have understood our representation of the vectors, I think we are clear by now that this magnitude represents nothing but the length of the vector. Now next we talk about equality of two vectors. Given two vectors, when they can be equal. Now since along with a vector two things are associated, one is magnitude and direction. So we can easily guess for equality of two vectors we will need both the magnitude and the directions to be same. So this is what we can see here, that two vectors are equal if and only if they have the same magnitude and directions. So if we are talking about two vectors A and B, so they will be equal if and only if mod A equal to mod B and the directions of A and B are same. Here in these figures, it's very obvious that A and B are equal vectors because we can see that they are having the same length and they are in the same direction. On the other hand, C and D, they are also equal vectors. Next we talk about negative of a vector. What do we mean by that? Now basically if we have two vectors A and B with same magnitude but opposite directions, then only we say that the vector A is the negative of the vector B and we write as A equal to minus B, where of course minus B stands for a vector of magnitude mod B and in the direction opposite to that of B. So basically this word negative vectors, this is another word for opposite vectors. We can also say in this case that A and B are equal and opposite vectors. Equal why? Because they are equal in magnitude but opposite in direction. So now next we will talk about some special vectors, and the first one in this pipeline is the unit vector. From the name itself, I hope we can guess what is that. Unit vector means a vector whose magnitude is 1, or rather the length is unity. Now we can understand that unit vector will just represent or indicate direction. Why it is so? Let us see the next point. If we have a vector A with magnitude mod A, we see that we can define a unit vector in the direction of A as the vector A divided by mod A. Now just have a look, vector A divided by mod A. So of course this is a vector whose length is 1 and direction, it is in the direction of the vector A. So then we can now understand that why we say that unit vector indicates direction. And the notation for unit vector, please note that it is written with a small cap sign, not with the arrow but with a small cap sign. So next we talk about the zero or null vector, and from the name itself again I think we can guess what is that. This is a vector with magnitude 0 or length 0. So how that is possible? How can a vector has length 0? But this actually means that the initial and the end point of the vector are same. So we can see that AA or vector BB, they are null vectors or zero vectors, as their initial and terminal points are coinciding. Now note one thing, that because null vector is a vector of magnitude 0, we actually cannot draw the vector because the length of the line segment is 0. So therefore it is not also possible to assign any direction to the null vector. Or in other words, we say that a null vector or zero vector may be regarded as a vector having any arbitrary direction, because we cannot assign a definite direction to it. Okay, the next one in the pipeline is co-initial vectors. So what are these? Two or more vectors having the same initial point, the same starting point, are called co-initial vectors. So in our figure here, we can see that AB and AC both are having the same starting point A, and therefore AB and AC are co-initial vectors. And the last one in this sequence is collinear vectors, and this is a very important type of vector. So what are collinear vectors? Two or more vectors are said to be collinear if they are parallel to the same line, irrespective of their magnitude and direction. So basically parallel vectors can be said to be collinear, or even vectors which are lying on the same line, they are of course collinear, and in that case we don't need to consider their magnitude or their direction, in the sense that whether they are, they can be opposite vectors basically. So in this figure, how many vectors are there? AB is a vector which is going to the left, AC is a vector pointing towards the right, DE is another one pointing towards the right. So see, AB and DE, they are of course parallel, but they are having different magnitudes, different directions also, but still as per our definition, AB and DE are collinear vectors. Similarly, AC and DE are also collinear vectors. Even AB and AC, we can say they are also collinear. So finally what we can see is that AB, AC, DE, all three we can say they are collinear vectors. Okay, so with this definitions and this special type of vectors, we will close today's session. In the next class, we will start with our main topic, algebra of vectors. Okay, so goodbye till then. Have a great time.